In this online presentation, Group 3 will present our group homework. The first question is to build the free body diagram of each member and build the internal forces diagram of member BFG. The first free body diagram will be this pulley with force P. P is pointing downwards, therefore the tension using sigma Fy would be P over 2 on each rope. The second free body diagram would be the member BH, which is under tension. The third one will be member EF, which is in compression. The fourth free body diagram will be the two pulleys which are interconnected. The tension from the rope P over 2 is written in black arrows, while the reaction forces is indicated with the blue arrows, which is all P over 2. The horizontal bar of AEF is drawn like this with AYAX, one single EF, and then BYBX. EF and BH are two force members. The last free body diagram is about member BFG. As you can see, the horizontal part of BFG has a force of P over 2 on the top going to the left. Therefore, a reaction force of P over 2 going to the right is produced, and a clockwise moment of P over 2 Newton meters. The reaction forces is the opposite sign on the point G. Also, the force F is reacted on the point F, and the reaction forces of the two pulleys are P over 2 on the P. There will be 4 cuts or sections in the BFG bar. The first one is between the edge and the force EF. The second one will be between EF and the first P over 2. And then the third one will be in between the P over 2, and then the fourth one will be the P over 2 and the edge. First, we will take the free body diagram of BFG, and we use sigma moment around the point P. Because we don't know EF, we can find EF using this method. We will find EF is equal to 3.542 P. After we find EF, we can use sigma Fy and sigma Fx to find By and Bx plus Bh. By will be found to be 1.125 P, while Bx plus Bh is found to be 2.334 P. Now that we have all the forces, we can now make the internal force diagram. The first section we will focus on is section number 1, or AA, that runs from 0 meter to 4 meters. The shear force indicated will be downwards. The moment will be anti-clockwise, and the normal. The first section we will focus on section A prime from 0 to 4 meters. The shear force will have downward force, normal will go to the right and moment will go counterclockwise. Then we use sigma fx, sigma fy and sigma moment at this point to find the normal force, the shear force and the moment of force in respect to x. These are the values. The second section, section B prime, runs from 4 meters to 8.5 meters. The direction of the shear forces and the normal force and the moment force is the same as previous. Then we use sigma fx, sigma fy and sigma moment around this point to find the shear, normal and moment force in respect to x. These are the answers found. The third section runs from 8.5 to 9.5 meters. We use the same method using sigma fx, sigma fy and sigma moment around this point. These are the answers obtained. Same with the fourth sections that run from 9.5 meters to 12 meters. These are the forces obtained in respect to x. Now we can draw the diagram. The first diagram is the normal diagram. From 0 to 4 meters we will use this answer of 2.33p. Then from 4 to 8.5 we use negative 0.5p. From 8.5 to 9.5 still negative 0.5, and 9 to 12 meters, 9.5 to 12 meters we will use negative 0.5p. The second diagram is the shear force diagram. The shear force diagram from 0 to 4 meters is negative 1.125 as stated here. Then from 4 to 8.5 it is at P, and from 8.5 to 9.5 is P over 2, while 9.5 to 12 meters is 0 as indicated here. The third is the moment diagram. From 0 to 4 meters there is a linear equation with respect to x, with reaching a maximum of negative 4.5 p at 4 meters. From 4 to 8.5 is another linear equation in respect to x, which is this one. It reaches 0 at 8.5. From 8.5 to 9.5, another linear equation with a maximum of 0.5p, this one. From 9.5 to 12, it is a constant 0.5p, this one. These are the three moment internal force diagrams we obtained from the bar BFG.
And now I'm going to explain about question number 2 about the power generator that is being delivered by a truck. So in this question, We divide it to two free body diagrams. The first one is the head of the trailer, and the second one is the flatbed of the trailer. In the question, there are several knowns such as the mass of the flatbed trailer, the pin, the fact that D is a pin, the cap, which has a weight of 8,000 kilograms, the theta of 30 degrees, and the weight of the generator, which is 25 ton or equivalent to 25,000 kilograms. The mu s of this question is 0.5 and the mu k is 0.4. We are asked about the distance from the generator's center of mass to the wheel C, and this is the free body diagram that we have discussed. This one. So first of all, we need to find the forces in D, which is the pin, and we use the xy coordinate with the with 30 degrees angle. So in C we have only normal force because the torque of the wheel is transmitted only to the rear wheel of tractor head. So it's only located in B, the the friction force. So to find the force in D, we need to find the weight, and we need to find the weight with Wt equals 7,000 times 9.81. The gravity is 9.81, and WL is 25,000 times 9.81. So first of all, we need to find normal C using sigma MD, sigma moment in D equals 0, and then this is the result with x being unknown. Next, we need to find the dx and dy in the pin D. In the end, we can find in here. So dx we can find only by using sigma fx equals 0, and this is the dx that we've solved, and the sigma fy to find dy. Next, we need to find the x by using the second FBD, which is the trailer head. We have unknown forces NA and B, static friction force in B, and that's about it. So first of all, we need to find NB. We can do it by using sigma fx. By using sigma fx, we have the knowns dx, wc sine theta, and the unknown friction force in B. The friction force in B is 0.5 times NB, the static friction, mu s times NB. And then we can find the NB here, and then using sigma fy, we can find the NA. Unfortunately, the NA found isn't the answer. So next of all, we use sigma moment in D again. Then we can find the real NA, normal NA. After we find normal NA, we compare it with the NA found from sigma fy, and thus we can find the X. Thank you very much.
So in this question, we have an excavator, and a force of 20 kilonewton is applied to the bucket of the excavator. And we're supposed to find the force at the hydraulic cylinders AC, DE, and also all the pin forces at member O, A, D, and B. So how an excavator works is that here we have the excavator arm, and it is equipped with a hydraulic cylinder at which are member AC, DE, and also GH. And basically, those hydraulic cylinders can extend or they can extend by the sliding of caused by the sliding of the hydraulic pistons. And our strategy to for the solution of this problem is first we have to determine the two force member, and the two force member in this excavator is our member AC, DE, GH, HI, and also HJ. And dry friction might also occur in the hydraulic cylinder, which are again member GH, DE, and AC, because of the sliding of the hydraulic pistons, as well as dry friction may occur between the bucket and also the ground. And how we solve the problem is by sigma moment and also the equation sigma fx is equals to
of this excavator will be right here. In this one, the unknown force will be AC, force AC, and OY, OX. And then we cut the section of the member EBF. It will be like this, because DE is the two force member, and the another join will be the BY and BX, and of course the 20 kilonewton right here. And then the next question is determine the force in the hydraulic cylinder AC and the pressure PAC against their pistons, which have an effective diameter of 95 mm. Determine the hydraulic cylinder DE and the pressure PDE against 105 diameter piston. Neglect the weight and of the member compared with the effects of the 20 kilonewton force. Determine the force at all of the pin at OADB. Okay, so first at this free body diagram, we should calculate the force AC. How can we do that? We do that with the sigma moment sigma moment equals to 0, and then we have the 20.3 20 times 3.95 plus AC, force AC sin 41.3. We get that from here, and then AC cos 41.3, and then point times 0.68 equals to 0, and then we get AC is the 97.633 Newton, and then we should calculate the right under question point D. We should calculate the pressure PAC, which effective diameter 95 mm. So will be right here, and then the pressure or the P will be the 13,773.56, and then we should calculate the OX and OY from the sigma fx equals to 0. We will find the OX. OX will be same as 20 minus AZ cos theta. It will be minus 53.35, and it will be force will be right into the left. Okay, same as the sigma fy sama dengan 0. Sigma fy equals to 0. OY will be AC sin theta. It will be 64.44. From the member ABF, we can get the theta of the DA, because DA is the force member, so we can make it just one just one force. And then from the sigma moment equals to 0 at point B, sorry, we didn't write this. 20 times 3.5 minus dA cos 11.3 times 0.73 minus dA sin 11.3 times 0.4 equals to 0, and dA will be 88.136 from, and then we should calculate bx and by. bx will be like this from the fx equation. Sigma fx equals to 0, and then we can calculate bx is 106.42. From the equation fy equals to 0, we can calculate, and by will be 70.27. Yeah, and then we get sorry and then we should calculate the pressure of the dA, and then we calculate it. Pressure will be F per A, which is 88.136 times 4 per P times 0.105 times 0.105. It will be 10678.41 Newton per meter cubic. Thank you.
Okay, so for problem number 4, and the problem is that after the power generator reaches the geothermal site, it is lifted from the trailer into the installation location using a crawler crane. So if the boom length is 12 meters and the hook can hold maximum of 70-ton load, determine the maximum working radius of the crane without causing the crane to overturn. As you can see that the specifications of the crane are written here, and that the center of mass is at the red dot below. So first, let's identify how the crane works. So obviously the crane works by attaching the power generator into the hook here, and then the crane will lift up the hook if it's in a safe working radius. So and then we will draw the free body diagram of the crane. So the free body diagram for the crane is, as we can see here, there is the mass of the crane itself, the normal force at the point of contact at the end of the crane tracks, and the weight from the hook plus the load itself. Now, as you can see on the table here, that the the hook weight we are using is the 800 kilogram one, which is the maximum load of the of the crane that can be held. So the weight of the hook is 800 kilograms. So you can see at the mass of the crane without the hook is 64 tons or 64,000 kilograms. The mass of the generator is 25,000 kilograms, and the mass of the hook is 800 kilograms. So now we must find what is the length of the working radius, which we define as the length between the center of mass of the crane and the position of the hook while it lifts the generator. As we can see from the length of the tracks here is 500, 5,195 millimeters, and we divide it into two. So we get the length of the center of the mass of the crane to the end of the track is 2,597.5 millimeters. So the distance of the working radius is the distance from the end of the tracks 2,597.5 millimeters plus the length from the end of the tracks to the length to the position of the hook. So now we can calculate the sigma of the moment and the pivot is at the contact point of the edge of the tracks. So the sigma of the moment is equal to 0, which the mass of the crane times the gravity acceleration times the length of the length of the arm, which is 2,597.5, subtracted by the mass at the end of the crane, which is the mass 25,000 kilograms, and 800 plus 800 kilograms times the gravitational accelerity times x, which is the length from the end of the track to the hook. So now we can move the equations. We can move the variables to the other side of the equation. So we get that x is equal to the mass of the crane over the mass of the hook times the mass of the generator times 2,597.5. So now we get that x is equal to 6,444.41 millimeters. So the working radius is the addition 6,000, the length of x plus this length, and then we get that the working radius is 9,040.91 millimeters. So that's it for the presentation from our group, our problem solvings. Thank you for watching and have a nice day.